Right, so we're looking at orbits, the way things rotate around things, and there's this planet called Jupiter. Great big red spot, usually renowned for that. Multiple bands of atmosphere that move in very strange orbits. It also has a close moon called Io. Ganymede, Callisto, Europa, all of these, not in that order by the way, I don't think. And this one here, Io, puts 3 million amps of energy onto Jupiter. Jupiter is really far away from the sun, but it gives out more heat, and it's got more internal heat than it receives from the sun. Our planet is stated that we receive heat from the sun, hence why we get so hot here. That's why it gets incredibly hot. However, we do have internal heat too, which is what is fundamental for volcanoes and everything else and tectonic shifts. So there is a slight internal heat, but there's more of a external, comes from the sun, atmosphere shift. Jupiter works a little bit different, and it's all because of Io. Io orbits, and it pulls the crust, and it stretches and squeezes the core. So it has a quite an interesting core, a metallic metal. So it's molten. And the moons, all of them are playing a role, but especially Io is pulling it. So if you take a teaspoon out of the drawer and you keep bending it, it gets incredibly hot. But that's only because you're only moving a percentage of the teaspoon at a point. So if you keep bending it, it will eventually break, but it gets incredibly hot at the area of bend. So if you could imagine, if you could levitate a spoon, and you could stretch and squeeze the whole spoon eventually, and if we were in space, this would turn into a sphere, yeah?
Yeah.
Much like a ball. If you could stretch and squeeze that and keep going, eventually, depending on what type of metal it is, it will start to spark, and it will start to generate a magnetic field around it. And what's more, it will go very molten, and it will start giving out lots of heat. All that is just imagine it. We can't do it on the Earth because the mass of the planet just doesn't allow this to happen, yeah? Works much more better in space. And plus our electromagnetic field will interfere with it. And anyway, so if we took this to space and we could stretch and squeeze this piece of metal, it would then become molten, liquid essentially, heated liquid, highly heated liquid. And the more you stretch and squeeze this and keep going, and all you would need is something to orbit it, 2 things to orbit it technically, it would begin to pull it. Because each orbit pulls on the core slightly a bit over here, then it's pulled over here, and it's being basically pulled apart and let go, pulled apart and let go. This would then begin to generate a lot of heat. In that heat, you have technically created, it's also known as the center sun. So the core on the planet is known as the central sun. You could call it that. Inside the planet, there is a star. But it's not fusing. Fusing is basically making hydrogen turn to helium, so it takes 2 atoms and slams them together. And then it makes one of this. And it does it again and again, multiple times. And then there's the next one on the table once it's got all of these ingredients. And again, until you get to iron. Iron is the most toughest thing that stars haven't mastered yet. Now, when we look at all of these, so we look at that as, we're just going to go Io. Okay, so we're going to call this intense orbits. Intense orbits equal heat. So, there is the famous Einstein. E equals mc squared. Times this by 2 gives you intense orbits, which then generates heat, which pauses the, it's not enough to reach a fusion process, and much of the, depending on what metal you're using, they're going to give out different heats, and therefore it's going to glow in a different way. Can you grow plants off of that? So let's say if we took a scoop of Jupiter's core. And it's very big. It's very, very big. Now, we took a piece of Jupiter's core and we put it here. It'll begin to cool down. Okay, so that wouldn't be a good thing. You wouldn't want it to cool down. But if you began to give it orbits, lots of orbits like Io, 3 million amps, that's insane. And let's say we put an object here, and it was just here and it was just orbiting. What it would do to the center mass, is it will begin to lift it towards it, and it will follow it. Now, because it's metal, it's a very dense liquid, so it doesn't flow quite like a river. Although it's very hot and it's trying to, the chances are the orbit will begin to lap, and this piece that's been peaked here will not simply flow across the metal object, because it's going to bump into a lot of cooler stuff. So it's probably going to let go of that and pick up this bit, let go of this bit, pick up this bit. Anyway, so that's just one orbit, probably not a great amount to do the heating process. Now, this heat here is suspended fusion. Now, it's either the material has already been in a star and has already been through the fusion process. Yeah. When we take it, it depends on what type of element that is, or what type of metal that is. So if we look at the planets inside the planet and we take the core, it's made of a lot of different types of metals, but fundamentally people say the iron catastrophe. You hear about the iron sinks into the planet. Steel is another one that produces when they heat it up, when they're going to forge steel, it begins sparkling. So we could understand that we've got two of those types of metals in our simulation, right? And what we're going to do is we're going to add another orbit here, which is now two of them that are going to be lifting this up. We're going to be bending this right out of shape. So we could sort of get a diamond, but we're not going to stop there. We're going to add another one. And we're going to add another one. These are, we could say these are moons, but they're very close. And they could be producing, let's say in our scenario, 3 million amps each one. Yes?
Yeah.
And let's go again. Let's make it like a compass, shall we? We'll go again, and we'll always do opposite. And these are going to orbit around. Let's go again here. And let's go again here. Now these are going to be the generators that are also going to drive this insane. So this is going to be peaking in all directions. And we're going to make this as molten as possible. And it's going to be lifting up parts of the area. It's going to be making this right out of shape. Because, again, liquids can be shaped, can't they?
Yeah.
Sometimes you can use vibration and different things like that. And you get nice patterns in liquid. There we are. So we're going to be bending this, stretching this and squeezing this. And the more stretching and squeezing we're able to do, we don't want too much because we don't want to start the fusion process. Because it runs into problems. But it's a possibility that we can go past iron using this process. And if there is any ET, okay? Some people believe in God, some people believe in spiritualism, some people believe in this. It's a new thing where people are starting to believe in ET. It's not really that popular. Do you know, more people will believe in religion. I'm not saying that religion is not okay to believe in, but what I am asking for you to do is believe in all of these possibilities, yeah? Especially ET. You are ET. Look on your planet. The planet is full of animals, insects. What are they? Other life forms. What is other life forms? Yeah, technically ET, but we say extraterrestrial, so we would have to then assume that we are interterrestrial, because we're in the planet. In terra. Yes? And then there's anything outside of terra becomes extra life forms. Anyway, so we're going to orbit this. We're going to be generating so much energy here that we're going to be squeezing this so much that we're going to generate heat. Now, we should ask about that heat, because what is usually heat? Well, we could say it gives off a certain amount of light.
Yeah.
So when things get hot, what do?
Light up.
And they glow, don't they?
Yeah.
Now, if that turns a reddish hue, that will be infrared. IR, so we'll put infrared, yes?
Yeah.
So if we've got energy equals mass, yes? I think it was what it was. Not really sure anyway, but let's understand. Most people take this Einstein quote. You hear it said a lot. Do you know what it means?
Yeah.
There you are. And we take IO, so intense orbits, equal heat. That heat is going to generate light, a particular type of light, depending on what it is, that is going to glow. If it's infrared, you know most solar panels are powered by infrared. Now, infrared is invisible, you'll think, yes? It's technically not true. It's only invisible when it's separate, individual. Remote control is invisible infrared light. But a fire, you know, a big coal fire, big wood fire, you know when it starts glowing that red?
Yeah.
That's infrared. So you understand that the star produces infrared light.
Mhm.
That's what powers solar panels. Could you imagine coating these objects here that are orbiting and spinning around here in solar panel? That would be interesting, wouldn't it?
It would.
Now, how you get the energy from there to this point? Well, you could then look at Nikola Tesla. What did he invent? More predominantly than anything else, what did he make?
I don't know. I think.
Electricity that can be sent wirelessly. That was one of his fundamental things he was playing around with, being able to send energy from point A to point B without needing pylons or anything else. It's incredibly risky on the planet. Internet is sending data. It's energy. One energy is coming to the phone, another piece of energy is moving away from the phone to XYZ signal, blah, 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 blah. This is wireless energy. So when you think about Wi-Fi signal, think of it as energy with little packets of data in it. You can also do this on the mains power. You know, the energy inside but it's quite a lot though, that is. But you can still send energy through data packets in electricity. That's interesting, isn't it? Interesting. You can also send it in light as well. So again, that is very interesting. All depends on where you want these photons, but there again, what would you grow underneath here then with all these solar panels around? Well, you could grow plants, couldn't you? You could convert that infrared light to power your solar panels, no clouds, no stormy day, and on the outside of these objects, so we'll say planets, moons. Let's call them moons. Should we call them tiny moons?
Yeah.
Or should we call them... We could give them M&M, couldn't we?
Yeah.
It sounds wrong to say man-moon, though, doesn't it?
Yeah.
So let's call them human moons. Hms. Let's call them hms, yeah?
Yeah.
Yeah? Let's call these objects hms. Now, let's say we have these big planets, like, I don't know, the size of our moon, yeah?
Yeah.
And they're all orbiting here. Now, if they're too big, this might create too much of a magnetic field, because that's the next thing. It will generate a magnetic field. So we move them slightly away. Slightly away, and larger objects moved slightly away from the planet, or this particular object, yes,
Yeah.
should diminish its pull. Therefore, it will draw down the intensity of this infrared and magnetic field. Too close, and it will generate more of a magnetic field. And I don't think we could ever get it to the Earth, but who knows? Inside here, if we have infrared, that's which so we'll have solar panels on there. Let's put some SPs in there then. Okay, so we got some and then underneath those panels, let's say if we made a biome
Yeah.
and a place to walk on, a platform to walk on if we needed to, but we create a layer. So what's better than an atmosphere? Well, we could make a glass atmosphere, couldn't we?
Yeah.
Technically, it's very weak, but still, you could do it. You don't have to use glass. We can use some other stuff, some other ingredients that are really strong. If this gets hit by little micrometeorites, it should deal with it. The solar panels on top? Probably not, but... Seen Stranger Things? A little bit of gel across there, self-sealing. Might rupture your panel, but there you are. It's more unlikely that it's probably not going to do that. But underneath that, what else could we put? Well, we're now underneath our little glass ceiling, we're going to assume. Above the glass are solar panels, which are grabbing the infrared light.
Yeah.
And now we're in a place like this. But it's not like this. Let's say if we've made these a bit more denser, where we've got multiple floors. Or what could we put inside there?
Like farms.
Farms. Yes, so we could grow food, yes?
Yeah.
Convert gases.
Oh, and cattle, like animals as well.
Cattle, yes. If we get a good enough gravity, yeah? Don't want them bouncing across a moon. Could you imagine a kangaroo on a moon? Put Neil Armstrong and Buzz Aldrin to shame when they were jumping, huh?
Yeah.
Kangaroos would fit right in, I think. You know, I think the astronauts were a little bit unsure about, they didn't really want to jump because they thought that they would jump off the moon.
And did they?
No.
So
But it's probably a fear because you're many miles away from home, right?
Yeah.
And even then, gravity becomes I want to stay to it. Yeah. So they found it very difficult to walk in that, so they bounced. They jumped like kangaroos. Which probably made their signals go AM. Good job we were not using FM to send the signal back, right? Because we'd be getting an AM. And then at NASA, they would have to then begin to rise up a pole to be able to catch the signal for every jump that they did. Obviously, it's a little different than that, but still.
It is.
FM, bit more of a straighter signal. AM is a bit more of a wavy format. They did this with Cassini. Some of the engineers at the Europe, and I think American, used different types. One was sending AM, and the other one was sending FM. So I think it was with the Huygens probe that when it went down, it was sending out this bouncy signal. The other one was only capable of reading it in a straight line. So they would only get bits of station. They would only get bits of the conversation.
Yeah.
So again, there's lots of problems, and they all get together and think, they tested it before they actually landed there. And that's as good. So then they made one of the probes go, was acting like a wasp in order to capture the signal so that it always got it. And that's how you turn an FM into AM. But yeah, it would have been nice if it just sent a load of data in a straight line. But no, we had to make that really confusing to be able to... It was like playing Pac-Man, but we're not playing it in straight lines. Pac-Man has to eat the things going up and down, yes? So whatever is giving all of those little dots, it's then going, you know what, actually, I think I'm going to give it in this signal. And then Pac-Man's like, yeah, I can deal with this. That's basically signal, if you want to help to understand signal. So when this begins to orbit, interesting. So we've got farms, we've got livestock, we've got gases now being generated, which, now, what about humans wouldn't live there? Probably not. What about if humans lived a little bit further away, in another orbit?
Mm-hmm.
What about here? Yeah, here. And humans lived on a planet-y type thing here.
Mm-hmm.
And here.
Mm-hmm.
And what about here? And one also here. And do you know what else we're going to be doing?
What?
We're going to be aggravating this even more. We're not making this intense. Do you want to see a piece of magic?
Yeah.
You want to see a little piece of strangeness?
Yeah.
Okay. Here's the interesting part, right? So, let's say if we take this as the centerpiece, yeah?
Yeah.
Wait, I did that wrong. I did that a little bit wrong. I didn't do it wrong, I just did it different. We're not up for the hmms yet, we're up for the ahs. We're going for the A's.
Alright, all the A's.
We're going for the A's. Let's make this a bit like the pyramids, right?
Okay.
So the pyramid we got, great big star in the middle, yes?
Yeah.
Let's make it a little bit like that. Oh.
It's like from a helicopter view.
Well, we could be looking at it that way. So we could look at the pyramid like this and the sun.
Yeah.
Or, don't get me wrong, could also be Orion. The 3 stars up there, yes?
Yeah.
Well, if you look at the pyramids from a certain angle, but is it possible that those Orions was there when the Egyptians were doing that? Let's leave you to play around with that, but still.
I mean, it is possible.
It is possible. So, we have got perhaps an Ankh. Maybe, who knows, right? Let's do a little bit more because we're not finished that yet. What if we did it this way? I'm scared.
Don't be
What do we have now?
A bigger pyramid.
What else have we got?
Connection.
Well, yes, connection. I mean, gosh, you're spoiling me with the stuff today. What are you beginning to see?
A star.
Oh, we're getting there. We are getting there. Slowly, the hamster got back on the wheel. And it's not running just yet. It's having a stroll. Here it goes. What else do we have? No, I don't see an there. Depends if I squint or not.
A bigger atmosphere.
A bigger atmosphere. You think that there would be an atmosphere in there? Could we have a spider's web? Could we have a sunflower?
Yeah.
What else have we got? We've got a star. Well, sunflower, star. You know, it depends how I squint, I guess. It's an interesting pattern, isn't it?
Yeah, it is.
We could say a mandala. With all of those, you know, the ones where you get to colour them in. I think I've shown you these before. It was a while ago. There was a whole book full of them. Some of them were half coloured in. Great stuff from charity shops. But the others, do you remember those?
I think, yeah.
Yeah, you think. Well, you just have to go through the suitcase that's through there and all your work is in it. So you can have a look there. And you can also have a look at your handwriting and see how it's progressed over the...
Oh, yeah.
You know, that's good to see that. Now, that is very interesting, isn't it?
Yeah.
Well, what happens if we just go a little bit more then, just for argument's sake?
Oh, my God.
Wait. First time I've ever needed an eraser for this.
Now it actually is turning into a sunflower.
You find that beautiful?
Yeah.
It's good geometry, isn't it?
What is it?
This. Now, all of these things will be going, what happens if we make it go this way and we make these ones go this way?
Mm-hmm.
And this one, you know, we'll see. Now, if we're living there, the gases that we will put in the farms would be carbon dioxide. So we breathe out carbon dioxide, amongst some other things, still. And then if we had the technology to be able to go, yeah, I smell that carbon. And not only smell the carbon, but we make an artificial lung. You see, when making a lung, one type of a lung for the human body, yeah, this will teach everybody all about how the body absorbs the oxygen and how the body releases carbon dioxide, yes?
Yeah.
Which is amazing. The body almost does this temporarily for you anyway, because of your blood. So if you cut and it's blue blood, and you had a slow motion camera,
Yeah.
the blood will come out blue. By the time it even hits the floor, the blood turns red.
Really?
Yeah. Everyone bangs on about this thing that you must be something very good. Why is that? Because you have blue blood, son. Blue blood is the best blood. Well, we do have blue blood. Just not copper, like an octopus, but still we got blue blood. Maybe it isn't, maybe it is. So, you know, even that is scared of blue. Ah, there you are. So before the speed of sight, before you can process that, and the speed of your brain processor, which is limited, so even if you try to concentrate on, I don't know, blood dropping down. Now, you could put this in a tank somewhere. Let's say we could have some large blood in a water tank. I know it sounds wrong, but let's just think about that for a second. And we turn all of that blood blue.
Yeah.
We starve the oxygen out of it, and we add carbon into it,
Yeah.
so the tank turns blue. And then another part of the tank makes the blood hit the air, the atmosphere, and then it begins to turn red. And then this red will come back into the tank, and the blue will leave.
Ah.
That's technically an artificial lung. So the hard part of the journey is looking at blood and thinking, my word, how does all of those little tiny bits of liquid iron inside your blood manage to oxidize like that? Because that's technically what it is. What do you have? Liquid iron. Enough to make a 9-inch nail if you could collect all of the iron out of your blood. They're quite a bit, right? Do you ever wonder where they get iron nails from?
That is not how.
No, that's not how. That would be pointless, but you could. One person per nail wouldn't even be enough to shut the lid on the coffin, sir. We're going to find some more iron. Where can we find some more iron? Well, we get loads of it, right? So You understand how that changes the coloration? Could you imagine it in this type of scenario? Now, this one over here is filling up a tank that is artificial blood. It's just as sensitive. By the time they've created all of this oxygen, the tank has turned incredibly red. Based on this thermometer and nature's window, right? This is a weird thing to think about, isn't it? Do you think that's a weird thing to think about? It is, isn't it? Like, so we got a tank, yeah? Now, depending on how we want to use it, now we've got to make 2 tanks. Why do we have to make 2 tanks? Well, because we've got one versus the other. My days. Right, but I did that one red, so that means red is coming out. Okay, so we're going to fill half this tank up with red, yeah?
Yeah.
Stop! And now we're going to fill the other half up with blue. And we're going to take it over here. Now, depending on what this is doing and where it is, and let's say that we can assume that there's a trough of blood somewhere. It's morbid as hell, isn't it?
Yeah, it is.
Alright, so we're going to draw a trough then.
Okay.
Alright? Yeah. Excuse my pet pig and its trough. They belch really well, by the way. Now, let's say that it's, which way round are we going to take this circuit? Well, we're going to have to do it the other way. So we're going to have a little pump attached to here, yeah? Right, so let's imaginary draw pump in there. Good. Pump. And its direction is going this way. So let's draw an arrow so we know which way it's going, okay? And then this one is coming this way, so let's draw an arrow the other way. Come on, look, we got to get with the arrows.
A cycle.
We've got we do have a cycle, indeed we do. So, when it starts to pool our trough of blood inside an environment with no dust and no debris, and assuming that it is a blood-like liquid, it's, by the time it gets to the end, it's a bit like a magnet, isn't it?
It is.
I wonder why we always colour those in red and blue. They don't pull out the ground. Oi, look, I found some red and blue. Shall we stick it on a police car? Make it go woo, 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 woo. Woo, woo, woo. Okay, fair enough. So, let's say, what are we going to be growing in here that's going to be generating a lot more blue in return? Well, it's going to be humans, of course there are, and animals and God knows what else, yes?
Yeah.
You're just breathing inside here. Don't worry about the trough of blood anywhere. It's just understand the process. This is what your body's doing, but in reverse. But this is just on an industrial scale. I know it's the size of people, but we'd need it the size of swimming pools if we made our artificial blood.
Yeah.
And just by living in the environment, breathing, this is going to change. Now, how do we knock that out of there? It's probably a very, very different story entirely. But even still, let's just assume that this works. Just get you thinking.
Yeah.
Just with us breathing, we've got to be pulling out some of this. This is going to change. So if this environment starts favouring carbon, we're going to be turning that blue.
Yeah.
Okay? And then the blue is going to go back into the tank until we squish all of this down. And this blood here is going to obviously reverse in... Wow. I've never seen it reverse. That's the interesting thing, right? But I've never actually taken any blood and made a room of carbon somewhere and then put some red blood in there. Does it turn blue?
Well, you never know.
Well, you never know, right? And is it because we're mainly oxygen? That's why we see it turn red from blue. But if we put this into a room where there's more... So we'd have to get a little bit more clever with this. This tank would need to be sealed in our artificial blood, right?
Yeah.
And we would need to bubble carbon into the solution so that the carbon blood would go this way. And the oxygen blood would be released this way. This one would be the exposure. This one would then need an air stone, maybe. By the time this turns completely blue, it's time to change it. And then this will become blue. And then we can put it into somewhere in the same process. Probably works easier this way, to be honest. Ooh, we shouldn't draw that in blue because it gets confusing. We're going to need so many arrows and shit. Right, let's do it this way. Okay, here's the trough. Okay, careful, we need the trough. Now this one's going to bring blue blood in from the bottom, let's say, of the tank.
Yeah.
So this one's going to be mainly filled with the blue. That's my signature. Don't tell anyone about that because, you know, I'll be able to take all of my millions out of my bank account. Trillions! Billions! I think trillions is more. We went backwards. It's all right. We'll settle on that. Don't be greedy. This one's going to be in reverse. Look at that. Look at that. So this one's going to bring the blood this way. So we need an arrow because it's getting confusing now. That's going to bring carbon. It's going to need oxidizing. I might have did this. Yes, no. We're going to stick with it. Just keep going on. Tell me, old son. And then this one's going to leave and go back into the tank this way. So we see we've got a reversal, yes?
Another cycle.
And another cycle? My word, where else would we ever see cycles? Oh, the whole universe, isn't it? Really? It's one big cycle, really, isn't it?
Yeah.
Recycle, cycle, recycle, cycle. Let's hope life cycles and recycles. Oh, wait, it does.
It does.
So we're going to have now, our magnet is going to be in reverse, isn't it?
Yeah.
Now we're going to have the red go in this way. Now, what on earth could we do in this environment? We've got stick people in here and animals. Yeah, don't forget the little oof oofs and the meows and the rat, the cat, the rabbit, the bunnies, the whatever you want to make that into. It's terrible, isn't it? It doesn't matter. It's all part of the story.
It just looks like a rat.
So what are we going to put in this environment then? All sealed off. I don't know about Urs. I've never seen an before. Oh wait, you mean Earl?
What about like bugs?
Bugs.
Bugs.
Okay, we just killed them all.
Okay.
No, they don't do very well with carbon dioxide. Not that I know of.
Mosquitoes.
Huh? They still don't do very well with carbon dioxide.
Slugs.
Well, maybe they do. Slugs.
Yeah.
Can we think of things that are green? They look pretty. They come out in the summer. Oh, are we narrowing it down?
Butterflies.
I quit. I don't. They make nice sounds when the breeze blows through their leaves. I mean, if I'm giving it that is like almost.
Okay.
My word, the hamster fell off the wheel, didn't it? It's all right. We'll get back on again.
I know.
Are you sure?
You know this bugs don't.
If we go to bugs one more time, I don't think I can narrow this down anymore.
But the bugs that look like sticks.
Oh yeah, let's put some stick insects in there. Yep, dead again. Oh my days.
Okay, what about birds?
I don't know, you're just pulling my leg. Serious. Okay, these things are green and you go stick insects, which I think they're brown.
What about leaf insects? Those are green.
The what?
Oh.
I don't know if the hamster just had an awakening, but something's going on in there. Is it the right answer though? What is it then?
Leaves like trees.
Like trees? Are we going like trees or are we talking actual trees? Okay, alright, yeah, okay.
I can't breathe.
Yeah. Neither can my intelligence right now. I swear now, man. Like trees. Okay, so what's like a tree then? A plant. Okay, Timothy. So we're gonna go like trees. So what else is good like trees?
Bushes.
Yeah, that's great. I mean, I'm sure we should just have some bushes and trees in this particular biome. I'm sure we'll eat this. We'll all become flowers.
Yeah.
I mean, flowers are nice, but most things are just a little bit more. You got it, nailed it perfectly here.
Okay, just leaves. Like leaves.
Mm-hmm. Yeah, but you know, you must be the most selfless human I've ever met.
I'm not selfless.
Most people, yes, that is selfless. Most people would be like, "Well, you should put food in there." What about lettuce for the animals? Fuck 'em! Putting all of this food is for humans only. You seem to be very selfless in this. So we're going to go with food?
Okay.
Because they do have flowers as well, you know.
How do they have flowers? Oh, what about fruit?
Oh, there we are. Hamster's back again. Hamster's back in the room. Yes, let's put in, like, fruit and... Are these the ums? Oh, yeah, those will be the ums. Don't ask.
So I'm gonna ask, what is that?
Not finished. Right, there we are. So we've gone pears, apples, cherries, grapes, vineyards, whatever. Look, let's just go
Strawberries?
nature. Strawberries, now we're getting there. Blueberries, yeah, all of that sort of stuff.
Raspberries.
Yep.
Blackberries.
Yep. Lettuce, fruit, tomatoes is fruit, but still cucumber, courgettes,
Potatoes.
mushrooms, probably.
Wait. What about vegetables?
I'd put mushrooms on their own. What about vegetables? Said the cucumber. Courgette? Ringing a bell?
Yeah.
Tomato, technically a fruit. Lettuce. Cabbage. Cauliflower.
Potatoes.
Or potatoes. Because I need my chips. No?
Oh, yeah.
No, yeah. But... Okay, so all of this. Then what are they producing then? They're sucking up all of that carbon. And then what are they producing?
Blood.
They're producing blood. Yes. Aren't they just? They are producing blood.
Okay,
Do you know, what type of exam would you take at the end of this? What do plants produce? Blood.
Well, blood.
What are we going to put inside of an environment like this? Well, it's alright because we've got the sp at the top, haven't we?
Yeah. Okay, so you asked me what do plants produce?
Yeah. We already nailed food. Good. So they're going to take in carbon. So maybe we need to draw this a little bit more. So humans breathe CO and 2, yes? Carbon dioxide.
Got it, yeah.
Okay. And then that's going to fill up in here. Then eventually this container will be all blue. Okay, and then we'll need to put another one in. But then if we were to move this and connect it over here, all blue, it's going to then start to produce red until it reaches all red, which is good for humans, I guess. This helps you visualize the gas exchange because we don't see it.
No.
We breathe, we feel it, but we don't actually see the exchange taking place. This helps you visualize that exchange of what is producing CO2, lots amount of. We might as well put cars in there, but there would be no need for cars. Which is going to move me on to another one.
What about aircrafts?
Aircraft.
What
aircraft.
about boats?
What about boats?
Yeah.
If these particular objects are small enough, did you know just elasticated... Think of a train that gets really fast up to speed using an elastic band.
It would snap, wouldn't it?
No, not if you made it right.
It would get hot. And it would snap.
Yeah, and then we put it on a bar. How fast could you travel around the moon?
Quite fast.
Just off a slingshot effect.
Quite fast.
Quite fast. You wouldn't need fuel. You would just need this process of taunting and... As long as the payload and you're strapped in well, this will push you around the moon without... The only energy you really need is to build this in the first time. So it's a bit like... if we took a... you have a Nerf gun that you cock, yes?
Yeah.
And then you can fire it.
Yeah.
Imagine that, but with a payload on it, on a moon, on a bar. An easy run bar.
Plus,
Every so often, it cocks and... If it was to do this, you would never need to fuel it up again. You just keep going on this because there's less gravity.
plus.
Even magnets can do this. Levitation. It's interesting, isn't it? Because there's less gravity, and there's less atmosphere. You see, when we walk around, we're fighting against gravity, we're fighting against the atmosphere. We just don't realize it because we're born into it. Neil Armstrong, Buzz Aldrin, first people on the moon, they noticed that. The missingness of this object. Therefore, it became almost impossible to walk through it because they became too powerful. So they had to bounce. And plus the spacesuits weren't all great. They were good, but not great. They're not like mobility because they were built very quickly. But now, since the moon landings, and it was many years ago, before my time, was it? It was. The technology has progressed since then.
Yeah.
Yeah, it's got better and better, so there's more mobility in it. So there's a few things for you to contend with, but less gravity. Did you know that if you were to play baseball, Americans play baseball, yes?
Yeah.
The ball travels, ball out the park in some aspects. I think like some of the Some of them have to tone it down a little bit. Not hit it too hard, you know, because if not, off it goes. You just take all of the points that you need, you know, right? But if they were on Mars and they did the same thing, the ball would travel even further. The ball would travel even further than it does on the Earth. And if you did it on the moon, well, I think you would bat the thing out the solar system.
Like a boomerang, maybe.
It wouldn't be a boomerang, depending on which angle you hit it. Hit it towards the Earth, and there's a possibility, but there again, that's a lot of numbers that you'd have to get that at the right
time.
So it wouldn't boomerang, but there would be a trajectory change based on the planet. Unless you hit it at the planet, then it just burn up. But if you were to do this on the moon, I don't think it would leave the moon's gravitational influence. It might. And there again, the new future spacecrafts on the moon. Ta-ta!
I got a question. So about this, the blood thing, because we've got humans and animals there, and we've got plants and everything else. What about fish?
Yeah, fish interesting. Any type of aquarium up in space, water takes on a unique shape. But 360, much like a ball. So if we were to take a ball, I don't actually have one here, it doesn't really matter. But if we were to take a ball and look at that, that would be how water would take its shape. So we then look at an ocean. Let's say if we lift the ocean up and we were able to encase it, we can even use water in some of these processes here, which we could then make tropical waters, which would then accelerate plankton and different things like that, which keep that whales happy. The only problem is with this, that type of life expectancy is only seasonal. In this, it would be 4 seasons all season. Life has to wait for summer to come round. You notice that, yeah? So when we go to the river in winter and you look in the river in winter, do you see any fish?
No.
No. They are there. They go in torpor. It's called torpor. They slow right down and they barely move. They conserve energy because there's not enough food for them to feed on, because depending on what they eat, so they hibernate in a way. They just slow right down. It's interesting. They barely move and they're really close to the side. They hardly move at all.
Are they like cold?
Coldness is a factor in what makes them go into torpor. They read temperature. They're not reading the light. They can barely see it. They can see it through the water, but it's light during the winter as well, you know. So they rely on the heat because they are reptilian by nature, although we don't call them reptiles. That would be wrong to categorize them like that. I will ask your question in a second, but when the sunlight hits the water, it gets warm. Fish are often very dark. Yeah?
Yeah.
And they bask first. So when the warm waters come in, this is what helps them to start to become mobile. As this warmth begins to enter the water, and the light too, but again, it's quite murky water, so, you know, it's scattering. So the water becomes warmer, and something else happens. When nature begins to start to open, all of the bugs from the trees fall in, and you see the water boatmen, the dragonflies, butterflies in certain circumstances, and also moths fall into the water, and as they do, the fish, so their food supply begins to expand. We often look at this. So in the winter, how much of that is around?
A lot.
No,
Yeah.
not a lot. In summer, how much of that is around?
A lot.
A lot. So you understand that they can get fed. If any of these, so usually fish will stop breeding if there isn't good food. If the food source diminishes in a river, fish will die. And first thing that you notice is they stop breeding. Then you start to see a reduction in the fish. And I tested this. I had a giant whopping tank. Feeding them flakes produced very little results, to be honest. But when you started feeding them live food, sounds a bit cruel, but it's just the way it is. So if you had plants above, the plants would attract insects close to the waterline. And some of these would fall in the water and they would go for this. That's an interesting thing. And then after a season or two of this, they then begin to breed a lot, which they didn't for X amount of years. They didn't produce any eggs. But then when there was this biodiversity of food entering into the top of the water, most people here in Britain close the top of the tank because they have fears of damp. That's an interesting thing because the water can evaporate and this, that, and the other. You can enclose this, but you've got to make it so that there is an insect habitat above, and the fish begin to grow. They get happy. They feel safe enough then. We've got to look at it from a human perspective, but we're trying to pack all of that into a fish. If there's lacking of food, what will humans do first? They'll stop having children.
Yeah.
What is the point in bringing kids into an environment like that?
Yeah, there's a point.
Right? So if this is true, it's brutal, but it's necessary. So if the environment is really bad, people stop having children. Then the numbers begin to falter. Because why would you bring kids into an environment such as that doesn't state it or is stable enough for it? So when you start seeing lots of fatalities in youngsters, this affects the population as to, I ain't having kids. And likewise is true if the parents die young. This can affect the outcome of having children. Did you know that? Really? Bloodlines tend to shrink off from this. It's just the way that it is. If the environment can't hold life, life stops producing life if the environment doesn't support it, and it begins to dwindle. And before you know it, your whole nation collapses. And when your nation collapses, then all of the authorities around it collapse. Then the whole structure finishes. If there isn't enough room to expand into, the same thing happens. This is the careful dance that humanity walks, but is never aware of it. This process here is only to teach you about what's happening inside your body when you breathe. It's just much more advanced, and humans have not figured this process out, and we often see it as invisible. This helps you to bring it into the visible spectrum, to then help you understand this, and this. And then what we could understand is then we have two types of lungs here, CO2 and an O2. You know, when we say that our lungs are, and I think another one is hydrogen is abundance, nitrogen as well. So when we've got this, what are our lungs really? Well, supporting on these factors. Do you see how we dance between a very delicate balance?
Yeah.
Between nature and life forms and nature and plankton and different things like that. So water in space, takes on this shape. Now, could you imagine whales in that? Anyway, it's a terrible whale, doesn't matter. That looks more like a dolphin, but still, actually a fish with a strange back. Can't remember what it's called now, but anyway. But if they were in this and there was a lot of plankton around these areas here that were orbiting, let's say, here, this would keep them in summer mode. And also the plankton would there again, if you were able to put this process in, would create a lot of oxygen. Our way is being able to sponge it up. Now, we have a fire alarm that is capable of dealing with monoxide, but what about carbon dioxide? And it's a very different thing to be able to suck all of this gas from the atmosphere. Could you imagine that, sucking in all of the carbon dioxide? It refuses oxygen, it refuses hydrogen, it refuses all the other gases. The only one that it lets into a cylinder and begins taking them out of the atmosphere. Yeah? That would be a very different way of cleaning gases. And then it begins to sort your gases. Okay, now we've got carbon in this one, which then I could take that cylinder and then screw it into a nature biome. And then I can begin to inject that gas slowly and steadily into the biome, along with a little bit of oxygen as well. We don't want it perfect. And then nature begins to And then nature begins to create oxygen and plankton and different things like that. There are many different things. We just look at nature as the one. And then we begin to take that gas. And on reverse, we have another sensor that's like a fire alarm, but this one is sensing oxygen in the environment. And not only can it sense the oxygen, so if we say that molecules are like this, then, yeah, let's say if we take a molecule, an oxygen molecule, and let's say, I'm not going to draw it in its correct format, I don't need to. There we are. So we could say that, and we could put on oxygen 2, anyway, never mind. And then let's say we do another one as carbon,
yeah,
which looks a bit more like Mickey Mouse, but still, that's monoxide. Anyway, let's say we do it like this. And if we were to be able to make our eyes so that we could see all of this gas, and we could tell the difference between the two from oxygen and carbon, what we want is an alarm system to not only be able to detect what's there,
yeah,
but also go out and grab the oxygen and then put it into a tank. So this is on a very small scale. We'd have to zoom in really far to see that. To be able to identify it and then put it in here. So we start to build this up with a gas of oxygen, yes?
yeah,
And slowly but surely, as it builds up, we can then begin to compress that, and then we can start to make liquid oxygen inside there, and we could make liquid carbon. It sounds really rare, but still. And we want another one to be able to take these molecules and put them into a container. You see, everybody builds fire alarms and then we stop and be like, okay, all done. And we want another one to take carbon monoxide. And we want to be able to put that into a tank as well. So let's do another one for monoxide. Very toxic. This is the killer gas. And we want to be able to take all of these and begin to put these into a environment. And once again, we want to convert these into a liquid because we compress it. When you compress gas and you keep compressing it, it then begins to turn into a liquid. You go beyond that and you start making isotopes. Isotopes is X amount of pressure, which then you would understand that the ocean is a certain type of isotope of loose gas is another isotope. Yeah?
yeah.
So gas in the atmosphere, compressed, makes liquid, go beyond under the ocean, and then you've got another isotope. Thicker liquid, then a thicker liquid, thicker liquid. Interesting. I often wonder if this responds the same way with metals. The skin, well, it's not as dense, and the isotopes of iron, they must be there, because if it's working with water from gas, then it must be, because we do have liquid iron. We have this, this, and this, and I wonder if we can have a gas iron. That'd be interesting. Probably too heavy to do so, but still. Yeah. Now we want to make it into a liquid, blah, 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 and the same with this one. Now, being able to collect these gases, the two that we're really eager to understand are these.
These two?
More predominantly than not is these two. They're precious. So, again, so what did we say this one was? Oxygen? No, we said this one was carbon. Yep, CO2. Let's say this one's CO2, is it? No, we did it the other way, didn't we? God, I'm confusing myself here. This one's going this way, so this one's taking carbon out. Okay, so we'll do that blue. And then we'll say this one is taking oxygen out, so that's O2, so let's do it this way. And we should put a 2 there, and then this one's CO, which is carbon monoxide.
Which is deadly.
Yeah, this is deadly. But the thing is, when we then zoom in again and we see the structure, we then see how it's held together, the bond. If we freeze this liquid, so once we've collected the gas and we put it into a liquid, and then once we've added the liquid and we put it into a frozen state, and then we expose it in, let's say, a stretchable balloon in space.
Yeah.
The balloon is not inflated, but the ice goes into the balloon. We're probably thinking not like a inflatable balloon, but not far from it. When we take this ice, put it into a balloon, seal it off whilst it's small, it doesn't look like it's inflated, and we move it closer to the sun. If we can allow space to influence that gas, it should be able to pull that structure apart, which then will expose what it's made from. And then, once again, once it's pulled it apart, go too close to the sun and it heats up like a comet tail that should be pulling it. If we take water to space, people say it boils, yeah?
Yeah.
That's not true. Technically, it's not true. It just means that the hydrogen and the oxygen are separating from each other. Now, if we can do that with the carbon monoxide, where it begins to separate, and we're able to capture that, we can then sort it again. And perhaps we'll have a tank of hydrogen. And then we can turn a deadly gas into one that is beneficial. And what's more, we can make the beneficial gases turn into deadly gases because we already know how to separate it. You end the carbon monoxide problem and you end problems with gases forever. Because then you know how to mix them, you know how to sort them. And this is really good because this one is particularly one side of a lung.
Yeah.
Nature's lung. Or plankton's lung, or bacteria, cyanobacteria is another one. When it dies, it breaks, it releases oxygen. This is one version of a lung.
Yeah.
And life forms breathe in another version of a lung, which is the retro, it's opposite. They're both opposite, mirror effects. Could you imagine being able to store this into a body with one and one? So that it puts carbon into one and exchanges it by it's got to start somewhere, but we don't visualize it. That's the interesting thing. But if we did, this is where we'd be at. So one of the rare earth mineral contents on the planet, do you know it's lithium is rare? Lithium goes into all mobile phones, pads. It's a battery. Where does lithium come from?
I don't know.
The earth. What created it? What caused it? Where did coal come from? Well, we could say nature. Nature, compressed under ocean layers. So every now and then the oceans move on the planet.
Yeah.
Yep. So if there was once a prehistoric forest somewhere else and it was growing and it was luscious and vegetation everywhere, and then the ocean comes and then it begins to fill up. More and more ocean water, and in a place where there was not much ocean water begins to drain away. Where it was ocean, full of ocean, begins to drain away, creates a new landmass. This one begins to fill up. Factor in heat, too much heat, not good for nature. Too little heat, not good for nature. Okay, so there's a happy medium, there's a summer environment. When this ocean water comes into a forest that we've got existing now, there are not many because they've been chopped down, but let's just say that the water moves in and knocks down an old forest. The water will become waterlogged, it will move and everything else, but eventually it will sink. If it brings in sediment with it, which usually when it's violent, when the oceans change, it becomes violent. It brings in a lot of mud with it and debris. So you've seen when there's a massive flood, how dirty is that water? If you scoop up a cup of it, you'll watch the sediment because it's in that fast flow. If you lift it out of the water, if you can get close enough, don't do it because it's dangerous, but you leave that cup to sit for a few days. There's about this much sediment in it and the water becomes clear again. That sediment is the part that when we've got to think this is ocean water. We're not talking about a flooded river and how dirty the water becomes. It's incredible, isn't it? Because it's churning up everything and it's eroding things. Rivers have been made to stay at bedrock level. But these levels here beside us have had vegetation, soil, stones, everything. And the stones that it kicks up, most of the rivers have got rid of stones. That's why the life is dying there too. Because when rivers hit into stones, it creates white water, and white water promotes plant life. That's why Thetford, you notice that at the top of the river, there's not much greenery. Where that water comes through that, where the mill is in Thetford, how much plant life is there? Loads. But there's not at the top. That one trickles very slowly. It's not creating much white water. This area is creating white water. And those little tiny carbon and oxygen and monoxide and everything else are getting churned up. And they're being thrown into the water. And then the plants that are there capture these. It sticks to them. Oxygen becomes sticky to plants and water becomes sticky to humans in space. This is a weird thing, isn't it? So when you're churning up all of this water, It's oxidizing into it, or it's carbonating it. Either or. It's what creates the plant life to grow. It's beautiful, isn't it? Don't you think?
Yeah, it is.
When you pay attention to it. When oceans move, and they do move, they erode the landmass very quickly.
Is that a good thing?
Yeah, it is, actually. It's good and bad. Depends, define good and define bad. Okay? When this comes in, it kicks up a lot of the softer material, and it's really easy to move the boulders, which then go into grinding all of this. If there's forest, they anchor in by root points. The sediment comes and blankets them. They begin to knock down, and then this becomes the bottom, depending if the ocean, river, or anything else settles above them. And then this begins to squish the tree in the sediment. By that time, it's already dead. Then it's bringing more sediment, and it's building up with more sediment and more sediment and more sediment, and it's creating more and more weight. This begins to squish the tree down. Prehistoric tree will eventually turn into coal. It's interesting, and the rotting process as well, and everything else that mixes into that rot process. You then get coal. You can perhaps get crude oil. Things like lithium can be made. This is the key question, or the hidden truth in it. It's all made. It's all made. All the rare stuff on Earth is made. It's manufactured and has been produced by the Earth. You want to make lithium? You find where it is. So there are coastlines that have this. There's a high presence of salt content. There are other ingredients into this, and when you can engineer, or you can backward engineer, what it's made from, and you shove all of these ingredients into an iron lung, we'll call it, and you go and make this get closer to the star. You put in other ingredients into it that are neutrals, which would be water. The more water you put in, and the closer you bring it to the star, the water inside there should try and steam, which would mimic pressure. If you can get this to fly through the sun, into that pressure, that dense crushing, while everything inside that lung is pushing outwards, the steam and everything else is trying to expand, but it can't. You prevent it from doing so. The sun will win and begin to crush it down, but you want to be able to seal it. Keep it so that when it comes away from the star again, what you should have in there are ingredients. Now, what those ingredients would be. If we were to take plant matter and put it in there the same way, mimic soil, pressure, and everything else, if we put it too far into the star, we'll create diamond. We're not making diamonds, we want to make coal. Can we extract oil from there?
Yeah.
This is because all of these things have been made on the planet. They didn't naturally occur. The star doesn't just explode crude oil.
It doesn't.
No, so there's a periodic table for the star that runs from here to here and then stop. The planet takes some of these ingredients, and then the processes that happen on the Earth begin to take those elements and go this way with the periodic table. The star is responsible for getting the planet to where it's at. Past star exploded, and we were made from the remnants of it. The planet's mechanisms, weather, rain, wind, erosion, are new elements, new influences.
Yeah.
Whereas the star's influence is very predictable.
Yeah.
We understand within a degree what it's going to make. Planets are variables because they have different weather patterns, different influences, and they begin to shape the ingredients in a different way. So the periodic table continues, and it becomes a sub-branch. And there again, you can pause and isolate certain types of these changes and then run this way. Then factor them into the changes that have happened in other planets or on other planets, on atmosphere dependent. And you take those ingredients that have gone this way, these ones that have gone this way, and you combine them both again. Now we start going zigzag. At any time you stop that process from changing from one to the other, you can then run it this way, or this way, or this way, or this way, or combine all of those things into a star. What happens if you take all of these changes that have happened on the planets, and they've shaped all of these different types of lithium and everything else, and diamond and whatever else, and we begin, as a humanity, begin to chuck all of these into a new forming star.
Yeah.
These were not formed naturally by the stars, but we begin to make a star of all these unnatural, variable, and we begin to fuse it. This is going to change the outcome of the periodic table. It can't create the same thing. because there's new ingredients now going in. And these ingredients didn't come from a star, they came from planets. But planets compared to stars are insignificant. Do you understand? They're too small. So those small changes are having an effect on the outcome of the next generation of stars, but it's never big enough. Humans, ET, intelligent life, gets to look at this and goes, what happens if we make a star out of all of that? The outcome is different. What that star produces at the end of it is completely different because the ingredients that have gone into it are now brand new. And the universe doesn't let all of these ingredients, they're like 0.1% compared to the average star here. Yeah. So they're a small amount of ingredients. The likeliness of this planet here collecting all of the stuff, the variables from the planet and forming something new is very unlikely. And then from another star system, they're so far apart. The black hole knows this. That's why it keeps things very far apart. And the only way the stars reach one another is if they explode at the right ratio at the right time, or one just before this one, then the ingredients rendezvous. That's why everything is such a distance. The black holes try and stop this process as much as possible. And in actual fact, humans, life forms intelligent, can make ingredients that have never been seen before. And that's where true intelligence comes from. How much of that database? And second, how much of that database have you already created? Because the more knowledge, the more ingredients. You're building a whole star out of all of these variables. Now that's an interesting thing, because even in the star's death and it explodes, if you were to collect all of these ingredients and make a fast factory, which would be a planet, so you could have 4 Earths, 10 Earths, 15 Earths, and you're running away all of these processes to make a large amount of these rare, to make those abundant, and you put all of those now rare Earth content, and you store them in the abundance, and you've got so much abundance that you've got enough to take care of your species, but now you have enough left over to form a star with it. The question of what if we combine that into a star?
Yeah.
It becomes a brand new thing that the universe is not capable of making naturally. Perhaps there are a few flukes, don't get me wrong. But in this process, anything gets smashed, the black hole will eat it. And when the black hole eats it, it's gathering intel. How to defuse it. The stars have spent a long time fusing this together and they've got ahead. Black holes have to do a lot of work in order to defuse it. We're trapped in a balance between the two. Anyway, these lungs and different things like this generate a magnetic field. It also looks like a brain, by the way, the center of your brain. It's interesting, all of these patterns. And you were to live on these, knowing that if you made a load of Earth around the sun, let's say we've got the star, and Earth is what? One variable that orbits around the star. Mm-hmm. What we're doing is adding more Earths around the orbit that all orbit together. And you can either keep these suspended where you make north, south, south, north, north, south, the magnetic poles. Yes?
Yeah.
We can keep these together and they will follow the orbit based on the right tilt. If they're charged up, which you can make a lot of. How many Earths can you make out of Jupiter? Yeah, we can make quite a lot, especially from the core. How much can we build around that? It wouldn't just be Jupiter, by the way. We'd need some rock. Because we need to make a crust to mirror image Earth multiple times. Which you wouldn't want to mirror image Earth because it's too unstable. But utilizing the star to crush ingredients. Well, you can produce diamonds. That's a mass. You know how to do it. The Earth showed you. You learnt from the Earth, if this process is correct, then indeed you will create diamonds if gone too far. But before cooking diamonds, what happens if you just put the object's carbon? Some people say that's carbon gas, which we could say, whatever. You've made from coal, which is very nice. If you buff coal, you see it's very, very pretty. It almost looks like an oil stain in water. But if you quickly flash fry it into the star and pull it out, you've created a large amount of pressure and oh, I've got this ingredient. Okay. If I do it twice, oh, I've got this ingredient. If you do it too long, you overcook it and you get a diamond come out. That's an interesting thing. But what happens if you take these diamonds and you go off to a giant star and stick them in there? That's crushing diamonds together. 2 diamonds crushed together should make a soft diamond. Repeat the process again. Oh, it's interesting. A very interesting process because you're controlling what the star can crush together. And I'm pretty sure the pressure will push all of these objects together, and they will give in because of the influences. It's interesting. It's like an oven.
Yeah.
We cook things in an oven to change.
To make something.
Yeah. So what happens if we take cake mixture and put it in a frying pan? We get pancakes.
Yeah.
Well, what happens if you change the ingredient a little bit more and put it in an oven? Intense heat, longer period.
Right.
It rises and you get cake. Most people say it's all down to the baking powder or the self-rising flour. I don't use any of those ingredients and I still get the outcome of rising. The heat is the ingredient. We often overlook that. Making stuff like this and exchanging your gases this way, one way or another, this ends energy crisis, this ends food crisis, and this ends land crisis. The one thing that the land is done at the moment, we live in a very stupid society, but also very intelligent. We just want to sell the top layer of the earth. How much for this land? Well, have you seen what's underneath it? No, just the top layer. I'm surprised, right? These people love money. Why have they not made the ground so that you can have multiple layers? It's a block of flats, but it's each land layer. We filter in the light using this process. And whether that is where you have a load of spheres dotted in the center of the land, so that when the sun chases over those, the intensity from underground, and we collect these to, I don't know, a bit like fiber optic, giant fiber optics that run all the way through the ground land masses. When the sun's over here, this column is more brighter. But by the time it's over here, this one's still bright, but this one's more intense. What will the plants do growing under there? They'll follow the columns. So what do you have? Sunlight that penetrates down into the ground. But it has a cost.
What's the cost?
What's the cost? If not done correctly, this will allow, if it's not, you see, because you need to encase it. So there's a field under a field under a field under a field, block of flats in the ground with a light column. The intensity, well, that would need figuring out. But it's interesting, the sun is radiation. What does radiation charge? Radiation.
Yeah.
If you had these columns, and when it starts to diminish, you were to encase safe enough to do so, radiation, this light should charge it. Not too much to cause devastation, and not too little in order to create this. Interesting, can we convert that into light? The answer is yes. But you need to seal it, because in those masses, it will sweat the water away, and this will leak into the atmosphere and puff the atmosphere up too quickly. But if you encase it, wow, interesting. And you got to get the right gases correctly. Well, it didn't work. Well, that would have been failed in space, wouldn't it? Where does they start in the ground, don't they? It's a training ground here. It's training. Anyway, it's not one I've really dove into enough. But the gases, exchanging of gases from one to the other, sending wireless energy, growing food. So the land at the top, either we are going to make power on it, or we're going to build houses on it, or we're going to grow food on it, or we're going to have livestock on it, or we're going to build businesses on it.
Is there another or?
Well, eventually humans begin to expand beyond the limits.
Yeah.
Well, how do you eat, grow?
Drink.
Well, there's another one, reservoir. So there's 6. Possibilities are endless to that piece of land, right?
Yeah.
How do you convert that land when you need houses? But now you've got an expansion of houses, now we need food. To feed the people in the houses that have the... And you keep on going and keep on going. And then you've got some people that have got many acres of land and they will not give it to anybody. And then you got to chop down trees to make way for more farmland. Well, what about a 7th one? Oxygen.
Oxygen?
Evergreen oxygen. Stabilization of atmospheric gases. the more you chop down these trees and rely on farm each summer. Did you know that this is recordable from NASA?
Yeah.
Well, because we've converted so much forestry and we've become dependent on seasonal food, we are slowly suffocating in the winter because all this food only comes out in the summer. Because of agriculture, we are tipping the planet's gases into the red during the winter. Then water life begins to suffer, ocean life begins to suffer, and that's because of farming. Evergreen tree will stay fixed for centuries, thousands of years have allowed all of these life forms to live.
Yeah.
When we convert it over with farmland, you've just cut down your bronchioles.
That's sad.
Yeah. So they say farming was the best thing that ever happened. Yeah, I wonder what our ancestors were doing, what they knew to eat. But they're not here to share the tales of the food sources that they could have.
Sadly not.
These are the consequences. And unfortunately, it will tip the scale so far beyond that no one will survive it if it keeps going unchecked. There again, if you made space farms around the Earth, you'd block the light out, again diminishing your oxygen supply. So you have to operate around somewhere like Venus, because Venus is a hothouse. You want to collapse the atmosphere down, and you get to it. I could deal with sulfuric acid in a lake somewhere, as opposed to it being in the atmosphere. It's easier to avoid. It's not so easy to avoid if it's atmosphere. Interesting, isn't it?
Yeah.
So you collapse it down. But you can orbit around that very safely with farms and have the food come back. It takes a while to send it. But deep space freeze, lacking in bacteria. I wonder what happens if you take a piece of food out into space and let the darkness pull it apart. You know, the same way, this is what happens when you take a cup of water into space, it begins to separate. Yeah, what happens if you take my salad up there? Bring it back down, because I want to eat it afterwards. Why the hell would you want to do that? I want to see if it alters the flavour. I've seen how cookers work, now I want to know how this stuff works. Freeze dry coffee, anyone? Just stick it in space. Space coffee.
I bet that would taste
We often look at the star and cooking, but what about freezing and pulling apart? I want to catch the juice that comes out of there. Why? Because I think that that's going to make a better drink. You know, the salad is going to be affected. Could you imagine catching all of the juices that come out of there? You'd understand how to make coal a little bit easier, or diamond. Here you go. You can have the food. I'll take the juice. Why? Well, you like diamonds, don't you? We all enjoy that. I'm going to drink the stuff that was extracted from that. Yeah, because space is going to extract it. You notice that it always wants the inners. Space is 1% of a black hole. The closer to the black hole you become, that's 2, 3, 4 onion layers. Space seems to be this. It really wants to pull things apart. At the molecular structure. When it gets iron, it's like, I can't deal with that. But if you just fly over there into that black hole, we will make good work of that. Which it will, because it's more concentrate. So it's an isotope backwards, whereas the star is an isotope forwards in the plus. Planets, plus. The deeper you go, the more crushing it becomes. Interesting. Anyway, this is fascinating.
It is very fascinating.
And I would ask, how many life forms have converted their planet this way?
I don't think a lot.
You don't think a lot?
It could be, but I don't know.
Well, that depends on how intelligent they are, too. That depends on how they place their eggs. Are they money-based, or are they survival-based? Are they intelligent? Do they imply their intelligence? That's the difference. And then we can all expand as life forms in this ratio, because you just keep building other layers onto it. And you can also make multiple of these. It's a bit like a Mayan calendar. It's interesting. Depends what you need the wheels for and the resonance frequency for as to what your outcome is. And Jupiter, after all, just sitting there, just beckoning to be played with. I just want to take a little bit of you. What do you want it for? That plan on making another Earth, but don't tell Jupiter. Don't worry, Io. It's all teaching you stuff. These patterns are teaching you. Fascinating. Anyway, right, let's leave it there. But still, water. Water in space. Could you imagine swimming in something like that?
Oh boy.
And the more central you got, that would create a intense amount of weight on you. It'd be good for astronauts to go into, to be fair. Or on umbilicals, because the closer to the center they become, it mimics gravity. Weird, isn't it? On the Earth, it mimics space. In space, it mimics gravity. Isn't that weird?
Yeah.
It's like, well, which are you? You've got two faces. And what was like, I know. Because when you're in the center of that, you've got a lot pushing down on you. At all levels.
Yeah.
Under the ocean, that is, we often mistake it. Do you know why we mistake it?
Why?
Because when we're swimming down deep, we never factor in, you've got a whole atmosphere sitting on top of you. Now you've got a whole bunch of ocean water, and the more deeper you go, oh man, it's beginning to really feel like it wants to crush me.
It's because I want to.
It's because there's a whole oh! Squish it like a fly in a hand. Terrible, isn't it?
Yeah.
Brutal, but true. But in space, you need that because you're missing the atmosphere. So it would mirror image the atmosphere, the pressure on you. And plus, it would be really good for morale. The astronauts, if they didn't have this indecent, I think, I would, if I ever had a space program, it would be an interesting one, Emilia. I would have fucking this. This would become a jacuzzi. Could you imagine trying to put bubbles in that? I don't know which way they would go. Do they center? Does it trying to? It could be an interesting thing. Has anyone ever tried blowing a bubble inside a bubble of water? Because it looks like a bubble, right?
Yeah.
How can I make glass in here? NASA, have you got a part on the International Space Station? Don't worry, we can snip it off if it goes wrong. Right, what do you plan on doing? Shaping glass? Seeing how it is on the Earth, I wonder what it's like up there. Bring down windows that are so transparent that no one can see them. We'd confuse every insect. It won't just be wasps and bees that are... The wasps are a bit more intelligent, but bees are like, oh.
Flies.
We'd confuse everything with the clarity. Any bubbles in here? No, sir. You made a magnifying glass on the Earth. You want to try it with one of these. Made in space. Oh my god, put it down. It'd be like a hose pipe. If you let go of it and it's on full throttle and it's starting to snake. Everyone, my mum was like, Terry, do something about that. And I was... Go and got my recorder, I actually didn't. But it was just pretend.
Then when you go to wash your car and there's those things that you wash it with. I don't know what they're called.
Pressure washer?
Yeah, pressure washer.
Okay.
And it is like really, really strong. I can't turn it off.
Yeah. But yeah, no, so I would have a jacuzzi in space.
Cross your head.
I would. It's now prehistoric. The astronauts were sort of showering like this. Now they just get into it. How's this? Oh, it stays cleaner for longer. Well, you are hardly moving and using a lot of energy in space. But how do you sweat?
Oh, yeah.
So you should be more cleaner. But anyway, even still, going inside that would be interesting. What do you think?
Yeah, I would think.
It feels a little bit like Earth if they could talk. You just have a pipe, snorkel, always reaches the outside, Exercise as well, all in one. The old ways of doing it in a gym. Swim through that. Oh, it works pretty well. Okay, now stick some fish in there. The aquarium, space aquarium. Anything? That would be incredible. Never mind trying to lift that water off a planet. No. Europa. Do you reckon Europa has any lithium?
I don't know.
Do you reckon it's got something else that's similar to lithium?
Maybe.
That's good at storing power. That's a lot of ice to melt through, but I'm sure it can be done. Interesting. Anyway, right, let's leave this here. But even still, could you imagine the International Space Station? It would be so different. Spherocoozy. That didn't come out right. I'll have another go at that. A jacuzzi that's in the shape of a ball. Ball jacuzzi. Bacuzzi.
That sounds fancy and expensive.
Yes. Oh, you can't drink champagne in this one. But even still, that would be good. And then being able to clean it as well. It cleans you just by going in it. No shower gel.
Oh, wait, what would happen if...
It would clean you anyway. Water's molecular structure is a fascinating beast.
Yeah, but what if you go into space wearing shower gel?
Well, you'd have to be cleaned before you went.
Oh.
And the water would have to be incredibly good. We don't want to be making mega fungus now. Turn it into a toadstool. But yeah, anyway, still, this gives you a way to clean the water. Yeah, impressive to be able to keep that even from freezing. Yeah, interesting. If you ever needed to clean it, what happens if we allow space to sort of have access, but we can hold on to all of that access? Put it into a gas, all the debris fall out. Little scrubbers go in and clean away all of those bad debris. Ding, ding, ding in the dustpan, and then we apply pressure again and the water... It's a great way to clean it, isn't it?
Yeah.
And even if there was algae or anything else, well... Goes back into the nutrients. We have a little bits of this. Anything that's not needed, well, we'll take that. Here we are. That goes into the dustbin. Here's what we pulled out of the water.
Oh my god, put it back.
Oh, you could purify water this way, couldn't you?
Yeah.
You could make two. One experiencing that whilst one is solid. And again, it depends if you're using it to scrub air. Because it's very sticky in nature, and humans by proxy are very dusty, so are animals. And then immediately it's starting to get dirty, and then this one goes back into pressure, and this one depressurizes. It'll, space is pulling on it, but it can't vent the gases. Yes, a cycle. Back and forth, back and forth, back and forth, and then you've got purification happening.
A never-ending cycle.
It becomes like a kidney in a space program. Wait, kidney? Liver? Either or. That'd be interesting. I'd like to watch that. Just letting go and repressurizing, depressurizing, repressurizing. Interesting. Yeah, dust particles stick to water. So if you take a large volume of the air, it's got to go through scrubbers and it blows into the water. That's going to pick onto the bits. The bits are interesting. They're going to be damp. But if you depressurize it, these will fall. Well, assuming maybe they'll stay in a clog because we're in space, but still. Take out all of that stuff. Don't need any of this stuff. This is the garbage. Can we recycle this into anything? Here, council, you're good at recycling shit. They do. They have the recycle centres, yeah?
Yes. I guess that's all they have good.
I was going to say it with God, though. Here, God, you want to take some of this? Yeah, I want to recycle that. Ta-da, here you are. It is very godly if you would say that the universe is doing this. It takes junk and it's like, oh, what can I do with this? Well, we've created stars, galaxies, and we've also created black holes from it. I mean, that is impressive. And everything in between. All of the elements, everything. Factor in a little bit of mind.
Yep.
I wonder what mind went into the universe. That's a question.
Maybe multiple.
I think multiple. Yes, I definitely agree with that. Multiple minds. Multiple intelligence applied. With intelligence on the inside. It all depends on how you use it. Anyway, right, let's leave this one here. Time is a ticking. Oh my god.